Good afternoon everyone, this is Jahnavi. Today I'm going to explain problems based on superposition theorem. So first we'll memorize the statement of superposition theorem. Superposition theorem states that in a linear circuit with multiple independent sources, the current or voltage for any element is the algebraic sum of currents or voltages produced by each source acting alone. So each source is considered one at a time. All other sources are replaced by internal resistances. So here are the steps to solve the problems. First, identify independent sources. Consider one circuit and other sources are replaced by internal resistances. That means voltage sources replaced by short circuit, current sources by open circuit. So solve the circuit with the remaining source active. Repeat the process for each source. Sum the contributions from all the sources to find the total current or voltage in the circuit. So here are the example problems. So first problem, find the voltage across through 15 ohms resistor using superposition theorem. So here is a 15 ohms. There are four sources. We'll consider each source and find voltage across 15 ohm resistor. So here is step 1, consider 20 volt source alone. So remaining sources are replaced by internal resistances. Here two current sources are open circuited and voltage sources short circuited. So here 15 ohms and 40 ohm resistors are in series. So our total is 15 plus 40, that is 55, and I1, that is the current through 15 ohms, is 0.363 amperes. So here we can find V1 as 5.445 volts. Now consider 10 volts voltage source. These two sources, current source 10 ampere current source and 5 ampere current source, are open circuited and 20 volts voltage source is short circuited. Here also same 15 ohms and 40 ohms are in series. So we can find I2 as 0.182 amperes. Now voltage across 15 ohm resistor is given as 2.73 volts. So now to find V3, that is voltage through 15 ohms, we consider 10 ohm current source separately, remaining sources replaced by internal resistances. So here 15 ohms and 40 ohms are in parallel. So by using current division rule, we can find current through 15 ohm, that is I3 is equal to I, that is 10 amperes, into R2, that is 40 ohm by 15 plus 40. So here I3 is 7.27 amperes. So voltage across 15 ohm resistor is given as 103.05 voltage. So now to find V4, consider this 5 ampere as separately and remaining are short circuited and open circuited. So this is a modified circuit diagram. So here in this circuit, this is follows low resistance path. So current through the 15 ohms is 0, that is I4 is equals to 0, and automatically V4 is equals to 0. So by using superposition theorem, V total is equal to sum of all resistances, I mean voltages. So V1, V2, V3, V4. So here V3 is negative because this indicates that the direction of the current in that case is assumed to be opposite direction in the circuit. So this is the problem. I hope you understand. Now next, this is the problem to find the current through 3 ohm resistor using superposition theorem. So we have to find current through this resistor. So now consider 20 volt voltage source separately, and this source is short circuited. So here we use nodal analysis. We may use nodal analysis or also simply by using Ohm's law. So here 6 ohms and 3 ohm resistors are in parallel, and resultant resistance is series with 5 ohm resistor. So by using Ohm's law, I total is equals to 2.857 ohms amperes. So I total means this current which is passing through 5 ohms. So here I1, by using current division rule, I1 is I total into R2, that is 6 ohm by 3 plus 6. So here I1 is 1.904 amperes. So we will here consider 40 volt voltage source alone, and this 20 volt voltage source is short circuited. Here also now we have to find total current. To find total current, total resistance is this 5 ohm, 3 ohm resistors are in parallel, and total resistance are series with 6 ohm. So by using Ohm's law, we can find I total, and by using current division rule, we can find I2, that is 3.174 amperes. So by using this superposition theorem, total current passing through 3 ohm resistor is sum of currents, that is I1 and I2. So by solving, we'll get 5.078 amperes. So this is the final answer. Next, problem 3. So we have to find current flowing through 20 ohms. This is the 20 ohm resistor. We have to find current passing through 20 ohm resistor. Here one is voltage source and current source. So consider first 20 volt current source. This is open circuited. So this is the final circuit. You can use here nodal analysis. So here consider voltage at this junction is V1. By using nodal analysis, equation is V1 minus 20. So here V1 minus 20 by 5 plus V1 by 10 plus V1 by 10 plus 20, as these two are in series, total is equals to 0. So this is the equation. By solving this equation, we get V1 is equals to 12 volts. That means a voltage across this junction is 12 volts. To find voltage or current, to find current through 20 ohms, we use V1 by 10 plus 20. So that is the current. So by solving it, I1 is equals to 0.4 amperes. So therefore this is the final answer. Now next, here we'll consider 4 ampere current source separately, and this is short circuited. So 5 ohm resistor and 10 ohm resistor are in parallel, which is supposed to be in series. So here A and B, consider these 2 points. So RAB is 40 by 3. So here is the modified circuit diagram. So these two are in parallel. So current flowing through the 20 ohms resistor can be determined using current division rule. So here I2 is equals to Is, that is 4 amperes by R1 by R1 plus R2. So by solving here, Is is 4 amperes, R1 is 40 by 3, R2 is 20 ohms. So we get I2 as 1.6 amperes. So current flowing through the circuit when only 4 ampere current source is considered is 1.6. So summation of this gives the current flowing through the 20 ohms resistor. So by using this theorem, we can find current through the 20 ohms, that is 0.4 plus 1.6, which is equals to 2 amperes. So finally, this is the final answer. Thank you. I hope